Hey guys, in this video we're going to do some binary conversions. It's going to be a little bit different from my other videos. I am going to reference them and use those functions. One I slightly enhanced or changed just a little bit. But basically what we want to do is we want to take in any number in base 10 and convert it to binary. Now, let me give you an example here where it makes it different from my other videos. Is that I had a video that converted fractions. So let's say 0.1 or 0.625 to binary, which is equal to 0.101. And then another example I had in my video is I had, let's say, the number 5. And I want to convert that to binary, and that gave me 101. Now what I want to do is I want to be able to put in a number such as 5.625 such that I get a binary number that is 101.101. So that is the plan, and hopefully we can get this working. So let me see here. I'm going to do number include stdio.h. Okay, and have my integer main function. We're going to have a double called num, maybe an equal 5.625 in this case, and we want a print statement, %lf converted to binary is %lf, and then \n to go to the next line, and going to need a semicolon there, and we're going to put in the num, and I'm going to put in a value there just to see if this is all running properly. And let's say this as a C file and call it binary conversion base 10. So save that. Great, 5.625 convert to binary is that. Okay. Now I'm going to go back to my toBinary function, and this converts a number to binary. So functions, these are functions that I've created previously, and I'm going to use that function there. And so this will give us what 5 is in binary, but we still need the 0.625, so I'm going to get my other function here. And so there we go. This function here semicolon converts a fraction to binary. Okay, and something to note, I have this original num here, and that's to make sure that I don't have anything repeating, any repeating digits. So you can have infinite binary numbers, just like you can have infinite decimal numbers, such as 1/3. But my compiler apparently handles this, so I'm going to get rid of this original num. If your compiler does not handle it, then you're going to want to create a double original num value, and then you're going to want to set original num. You're going to want to set it equal to your num. And it's going to be actually not just your number, it's going to be specifically this portion of the number, and that's what we're going to do here. Is we want to get the integer, so I'll call it int num, and this is going to be the integer value of num, and the original number is going to be the integer number minus the original num. Or we can also put a double here, so double, and I'm going to call this the float num, and that's going to also equal this value here. So now we can just say, well, float num is going to be the number that we're going to input into our decimal float to binary function. So I can just say that is equal to this here. Okay, so let's go ahead and do this. What we need to do is we need to check if well, actually, well, all we have to do is we need to get our answer, and our answer is going to be our two binary function. So let's grab that, and I'm just thinking on the fly right now, just of how I'm going to write this and how we're going to program this. So our two binary is going to be our integer number, and it's going to return some binary number, plus our decimal float to binary, which is going to return the float of the number, and we need to put in float num, and then semicolon. Well, I'm just going to just take this here, place it here, and we might want to set this equal to a variable, so I'm going to comment it out for now, and let's see what we get. Original num. Oh, ha! I misspelled original. So let's go here. Put original here. Now let's run it. Doesn't look good. Okay, so let's see what we did wrong. Let's not do this float one yet. Let's run this. 5.625 converted to binary is apparently let's do %d, and again I'm just doing this on the fly, so okay, so we get 101. Maybe I need to make a variable float or a double and call it answer and set that equal to this. And because that returns, this returns an integer plus a float, I'm guessing I need to cast this whole thing as a double. So let's see. Let's try this. Let's comment this out. Let's put lf here, and let's just put our decimal float to binary, and let's see what we get here. So I think we found our problem. Let's let's cast this here as a double. And we still get that issue. Okay. So our num is a double. Let's see what we're getting here. Let's do a print statement. Printf float num is equal to %lf and float underscore num and we get a negative number. That's not what we want. We get a negative number because I am subtracting the wrong way. So what we want actually is the number, because the number is going to be greater than whatever integer num is. And that should actually solve that problem. Good. Alrighty, and now let's try to put answer here. Yes. So we can comment out this. And that should be it. Let's see. Yeah, 5.625 is 101.101. And let's try another number like 2.625. We get 10.101. So thank you guys. I hope that that was helpful, and I actually like to see those mistakes happen because it allows not only for me to learn more, but it also allows you guys to see how I can kind of go through and debug things. So that's it, and thank you guys, and I'll see you on the next video.